Hello everyone, how are you all? Welcome once again to the chemistry class. So let's begin with today's class. As you all know children, in your chemistry class we are dealing with the chapter The Structure of an Atom, and in today's class we will be discussing about the next atomic model, that is Niels Bohr's atomic model, as well as we are going to talk about electronic configuration. So let's start with it. So children, in order to overcome the objections raised against Rutherford's model of the atom, Niels Bohr in 1913 proposed an atomic model. This model of an atom states that an atom consists of heavy, positively charged nucleus, and the whole mass of the atom is concentrated in the nucleus. The electrons in an atom revolve around the nucleus in definite circular paths called orbits or energy level. The energy level is associated with definite amount of energy. The change in energy takes place when electron jumps from one energy level to another energy level. So children, this was the model proposed by Niels Bohr, and this is the most accepted model till date. So with this diagram children, try to understand the atomic model proposed by Bohr. From the figure, it's very clear that the center portion of the atomic model given by Bohr was the nucleus, which was of course having two subatomic particles in it, namely protons and neutrons. And the outermost shells or the orbits, which are also known as discrete orbits, are named as the shells: K shell, the first shell, L, M, N, and so on. So you just have to remember this. The starting of the name for the first shell is from K, capital alphabets in English, K, L, M, N, and so on. Yes children, Bohr also got the Nobel Prize for this work on the structure of atom in 1922. So now children, we are going to discuss about electronic configuration, that is arrangement of electrons in an atom. The arrangement of electrons in various shells or energy levels of an atom of the element is known as electronic configuration. The maximum number of electrons that particular shell, that is energy levels, was given by Bohr and Bury. According to Bohr-Bury's scheme, the maximum number of electrons that can be accommodated in any energy level is given by the formula 2n square, where n stands for the number of shells, could be 1, 2, 3, 4 and so on for the shells, namely K, L, M, N and so on. The maximum number of electrons in the outermost orbit will be 8 electrons, even if it has the capacity to accommodate more electrons. This is something very important children. Even if it has the capacity to accommodate more electrons, but it cannot have more than 8 electrons, the last shell. Electrons are not accommodated in a given shell unless earlier shells are filled. That is, stepwise filling of the shells is followed. Orbit. The circular path around the nucleus is called orbit, energy level or shell. Energy levels are represented by English alphabets K, L, M, N and so on. This I've already told you. You have to be very particular about these names. Therefore, first orbit is denoted by K, second orbit by L, third orbit is denoted by M and so on. So distribution of electrons in an orbit or shell can be obtained by using formula 2n square, where n is the number of that orbit. I hope children you have understood it. To make it more clear to you children, let's discuss an example. Suppose the number of electrons in K shell, that is the first orbit, we have to calculate. Here the first shell means n has to be number 1. So the formula 2n square, when we are going to put the values, the answer will be 2. So this means the K shell can accommodate maximum number of 2 electrons in it. So if we want to calculate the number of electrons in the second shell, that is the L shell, then the number value for n is equal to 2, and by putting 2 in the formula 2n square we'll get the answer 8. Thus maximum number of electrons in the L shell will be 8. In similar way, Maximum number of electrons in any shell can be calculated, and we can do the distribution of electrons, that is electronic configuration, very easily by using the formula 2n square. Thank you, Shemstars. That's all for today. You can drop your queries if you have any on the Google Classroom. Take care. God bless you all.